In this video, we're going to go over how to make a part in Altium for the situation when you found the part that you want to use, but the footprint isn't available for you to download. So I have just a blank project here, and we'll go through how to make an example part. Every component has the schematic diagram, which is this, the schematic symbol, which just shows the pins, and the footprint that shows up on the PCB itself. Close this. So there's the footprint right here. It doesn't matter what the schematic looks like, but this part has to be correct or else your part will not fit. So we'll go ahead and get started. We're going to make this part a right-angled header, and we'll go ahead and make the 6-pin version because that's what's shown here, although this sheet has options to make any number of pins. Every component is contained in a library, so we'll go ahead and right-click here, add new to project. We'll add a schematic library for the schematic symbol, and we'll go ahead and add a PCB library instead, or in addition, and that's where the footprint will be. So we'll go ahead and start making our schematic symbol. It doesn't matter what this looks like. Its sole purpose is to show the pins that are part of this component. So we'll access the place menu here and just place a rectangle. And since we're making the 6-pin version, we'll just go ahead and place 6 pins. You can access the pins here or also in the place menu as well. We'll hit Tab and edit the designator. We want this to be pin 1 because it's the first pin, and we'll also go ahead and name it 1. The name doesn't matter unless you have a specific purpose for this pin. Like if I knew that pin 1 had to be ground, I would go ahead and name it ground to make my life easier when wiring everything. But it doesn't actually matter what the name is. Notice the side with the X is facing away from our schematic. Alright, and that's it for this part. That's all there is to it. We'll go ahead and change the designator for the item as a whole. We'll call it H question mark. And the question mark will be replaced later by a number when it's put on the actual schematic diagram. Then we can rename it. We'll call it right angle header 6 for 6 pins. And then we'll go ahead and save. Save. And then that's it. So now we're going to make our footprint, which we will then link to the schematic diagram. So we'll refer to our diagram here. This sheet gives us a nice layout for the footprint. Not all of them do, but this one does, so we'll go ahead and follow it. Here are our 6 pins, and these are just mounting holes. So we see the hole here has to be 1.09 millimeters in diameter. So we'll go up here. This is place pad. You can also access it from the place menu again. And then that is not the right size, so we're going to go ahead and hit Tab and edit this. Designator, we'll call it 1 because we want this to correspond to pin number 1 from the schematic diagram. then we'll edit the whole information. Notice here the units are mils, and on our data sheet, units are millimeters. So we'll go ahead and type in 1.09, specify millimeters, and it'll convert it for you. And then we'll edit the pad size. Usually about 30 mils larger than the hole size is safe, so we'll make it 70 mils. In diameter. Alright, and then it'll take care of these for you, so you don't have to worry about those unless you have something specific in mind for them. We'll go ahead and place this at the origin, just because, and we'll place 5 more to total 6 pins. So we've got all our pins. We'll go ahead and change the pin 1 to a rectangle shape. It's customary to do that just so when you're looking at your PCB you know which pin is pin number 1. And then we'll put them in the right position. So here it shows they're 2.54 millimeters apart, and then they're all in a straight line. So we can, this one's at the origin, we're good there. And then we'll go ahead and click pin 2, unlock the position, change this to 2.54 millimeters. And it'll convert it for us. And 0 mils, that's fine there. Then we'll lock it in place. Turns out this is 100 mils, so that's going to make our life a lot easier. We can just add 100 mils to the next one. So this will be at 200 mils. $300. 400 and 500 mils, and this should be 0. So now these are all in the right position relative to each other, and we just need to add the mounting holes. It shows the mounting holes are 3.4 millimeters across, so we'll start with that. We're going to use the same place pad symbol, hit tab to edit the size, and then we'll change the designator instead of just a number to usually some letter plus a number. I've seen them notated, I've seen mounting holes notated like this, so that's how I'm going to go ahead and do it. But if you leave it as just a number, it'll register as a pin. So that's why we're changing it, since there's no electrical connection there. We'll change the hole size to 3.4 millimeters. And then we'll go ahead and change the pad size here. Since there's no actual electrical connection, it's not being soldered to anything, we'll just make the pad big enough to clear the hole. So we'll go ahead and add on about 10 mils. This is 133, so we'll make it 143. And then we'll place it in approximately the right place. It was here-ish. And put another one there. And now we'll go back and refer to the diagram to put it in the right place. It shows it's 1.4 millimeters to the left of this point here. This is our origin point. And 8.64 millimeters down. So we'll edit this one's location. Negative 1.4 millimeters, and this is negative 8.64 millimeters. And then this one will be 1.4 millimeters to the right of this and 8.64 millimeters down. We know that this is at 500 mils already, so you can convert it yourself and type in your result, or you can just type in 500 mils plus 1.4 millimeters and it'll do it for you. And this should be negative 8.64 millimeters again. And there we go. This is really all you need for your footprint, but I also like to include an outline of the component itself in the top overlay layer. So we'll go ahead and refer again to our diagram here. It shows that this is 13.59 millimeters long, this side, and then it also gives us the exact width as well, if we added these together, but we're just going to go ahead and guesstimate since this is really only for placement. So we see that this is right at the edge of the mounting hole, so we'll go ahead and put it there, and that should be good enough. So we'll place a line, one vertical line here. We'll edit this. Length should be 13.59 millimeters. And we'll place it in about the right spot. And this is just to help when you're laying out your board, so you're not accidentally overlapping footprints and putting something here that would conflict with the actual part itself. Alright, so that should be good. We'll go ahead and clean this up. And then that's it for that. We'll go ahead and click into our PCB library tab, double click here to rename this component. We'll call it the same thing as the other, right angle header 6. Okay, and then we'll go ahead and save again. Okay. So those are the two parts of our schematic symbol and footprint, the two parts of our component. So we're going to go over here, and the last step is to link them together. So we'll go into the schematic library tab and click add footprint here. And then we're going to hit browse and find this model. So here's our model right here. If it wasn't in the first library that popped up, usually this will show some libraries, and then if it wasn't there, you can go here and search through all the libraries that you have available to you. Go ahead and hit close. Okay. Okay, and that should be good. You can add multiple footprints. Say if you also had a straight version of this, like a non-right angled header, it wouldn't have those mounting holes. So you could have the same schematic symbol with a different footprint to save some work. But we'll just keep the one. We'll save this. And then, if we go over to our sheet, delete this, we don't need it anymore. We open up the Components tab. The library should show up right here. We want to click the schematic library because this is the schematic sheet. And there's our part. And we can rotate it just like any other part by hitting the space bar. And then, because the question mark is there, if we go to Tools, Annotate Schematics Quietly, it'll update it to a 1 for us. And then, if we go to our PCB, because they're linked together, this shows up as well. And it knows that this is pin 1 and this is pin 6. So that's all you really need to do to make a part. If you had to make several parts, you can of course add them all to the same library by opening up the library tab down here and clicking add, and you can add a new part. Go ahead and cancel that. If you had made several parts and you wanted to send them to somebody else, it might be a good idea to consider making an integrated library. Integrated libraries are nicer for sending around because it's only one file instead of these two separate files, and also it'll check for errors when it compiles. But it's not as easy to edit those, so if you're in the process of adding parts to your library, I would go ahead and just leave it like this. But if we want to make an integrated library, you can hit File, New, Library, Integrated Library, and then we can add these two documents to it. So we'll go ahead and right click, add existing to project. We will find those two libraries, here they are, and add them. We'll save this. Save. We're going to save it in here. Yes. And then we can go ahead and compile. And then this will create another file which has the integrated library itself. So we can add that file to this project. We'll add existing. And here it is, project outputs for integrated library 1. Integrated library 1. We open it up, and there's the library. Open. So now it's part of this project. If we go back to our schematic, we click the drop down here, here's this library, and there's the part again. And if we update the PCB, there's our second footprint for that one. So that's all there is to it. I hope this video was helpful.